So now if I go to the fourth one, um, there are the topics binomial, normal. So in binomial Poisson distribution, you can do both the same question by both variables as well. But in binomial distribution, you need n and p. If you have been preparing for the exam, of course, you know what that is. If x is a random variable who has a binomial distribution, right, with n and p are called parameters. Uh, this means x has a binomial distribution. What is n? N is total number of trials. Total number of trials in an experiment. For example, if I toss one coin 3 times, it means n is 3. I am repeating my trial 3 times. And P is a probability of success. Whatever your success is in one trial, what is your probability of success? Let's say in tossing of a coin, my success is head. So what is the probability of head in each trial? It is 1/2, right? If we toss 3 coins together and let random variable x be the number of heads, in these 3 trials, right? Then your x is a binomial distribution, right? X is a binomial distribution with n is equal to 3 and p is equal to 1/2. Why? Because we are tossing 3 coins, so n is 3, and because we are treating heads, so probability of head in one trial is 1/2, right? So this is your binomial distribution. That's how you can recognize n and p. You need number of trials, p the success probability. Now, then if they ask you what is the probability of x, taking a small x, it is ncx p to the power x 1 minus p to the power n minus x. And x goes from 1 to n, 0, 1 to n. So for this example, if they ask me what is the probability of x successes, x heads, it will be 3cx. P is 1/2 to the power x, and 1 minus 1/2, which is again 1/2, 3 minus x. And x will go from 0, 1, 2, and 3 only. Okay, up to 3. Now you can ask me anything. You can ask me what is the probability that 2 head occurs. Let's say they ask, find the probability of getting 2 heads in 3 tosses. It means you have to find probability of x is equal to 2, right? So that will be 3c2. I will put x is equal to 2. X is 2, so I can put it here. 1/2 to the power 2, 1 minus 1/2 to the power 3 minus 2, and get the answer. They can ask you what is the probability of getting at least, probability of at least 2 heads. At least 2 heads. At least 2 heads means probability of x greater than equal to 2. At least 2, right? 2 or more. So it means I have to find 2 probabilities, 2 plus 3, because it cannot be more than 3. So I will add these 2 probabilities. So 3c2 half 2 half 3 minus 2 plus, for x is equal to 3, it will be 3c3 half 3 and half to the power 3 minus 3. This is 2. 3 minus 3 is 0. 3 minus 2 is 1. So you can directly write that. Now you can find these 2 probabilities separately and add them. Right? Get the answer. So it's not difficult. Binomial is not difficult at all. You see here, uh, in testing, I think I did all these things maybe. Uh, According to a survey by some society, one half of US companies give employees 4 weeks of vacation after they have completed 15 years in some company. Let's say you are working in some company and you have worked there for 15 years. Now they will give you 4 weeks of vacation, right? So he said, find the probability that among 6 companies surveyed at random, so it means N is 6, the number that give 4 weeks of vacation anywhere between 2 and 5. So he said out of these 6 companies, from 2 to 5 companies give 4 weeks of vacation, or fewer than 3 companies give 4 weeks of vacation, right? So I got n is equal to 6 here. Assignment number 4, 4 or 3. Assignment 4, question number 2. So n is 6 here. Just give me a minute. So n was 6. But what is p here? What we are asking? We are asking uh, number of heads, number of successes. So what is my success? Success is getting a 4 weeks of vacation, right? This is a success. How many companies give you 4 weeks of vacation? So what is the probability of getting 4 weeks of vacation? They said half of the men. Half of the men get 4 weeks of vacation, right? You see here? One half of US companies give 4 weeks of vacation. So it means, so first I have to define, let X be the number of companies who give 4 weeks of vacation, that give 4 weeks vacation, right, to its employees. So then your X is a binomial distribution with NP, where your N is 6 and P is 0.5, because 50% of the companies give you 4 weeks of vacation. So now the after that, so this is the step one. Step one is write X, whatever, where X will come from. X will come from your question, what they have asked. What is the probability that out of 6 companies, how many companies give you 4 weeks of vacation? So I said, let X be the number of companies who give 4 weeks vacation, right? Then X is a binomial distribution and write N and P. After that, step 2 is write down the formula, general formula for the binomial. X is equal to small x, NCX, P to the power X, and 1 minus P. 1 minus P is also 0.5, right? Which is 6 minus X, N minus X. And X is 0 from 0, 1 up to 6. So from here, you can find 1 minus P. 1 minus P is 1 minus 0.5, which is 0.5, right? So we got both. So this is my formula. Now you can answer questions. So step 3 is now you can answer questions. Put X, right? So now answer questions, whatever they are asking. So first part was, what is the probability that from anywhere from 2 to 5 give you 4 weeks of vacation? Is that? See, anywhere between anywhere from 2 to 5, it means 2 and 5 are included. So 2, 3, 4, 5. So you will write 2 because it's a discrete variable. It does not give you probabilities in the interval. You will go to 2, 3, 4, 5. You will not use integration here, right? There is no PDF. This is the probability formula. So you have to individually find probability of x equal to 2, 3, 4, 5. There are no values between that. So now you can put 2, 3, 4, 5 in this integral and write the answers. 1, 2, 3, 4. Get the answer. Okay. So that is, I think, simple. Then they said fewer than 3. Anywhere fewer than 3. Fewer means less. Less than 3. So less than 3 means 3 is not included. So it will be 0, 1, 2. 0, 1 and just 2 because less than 3. 3 is not included. If they say at most 3, at most means less than or equal to 3. So you have to remember this. So again, you can complete this one. Remember, at least means greater than or equal to. At most means only less than or equal to. But if they just say more than, right? More than or greater than, then you don't have equal sign. Remember, equal sign is not there. If they say less than or fewer than, right, then it is less, no, without equal. So less than and at most, they have less than sign, but at most have equality. But this does not have equality. Similarly, more than has greater than, at least also has greater than, but at least also has this equal sign. Means the end points will be included in at most and at least. What else? If you have any questions, you can ask. No questions, so see, people are leaving, so they are bored. So maybe you already know all these things. I don't know. I'm wasting time here, maybe. So Poisson distribution is in Poisson distribution, if x has a Poisson random variable, right, p, it has just one parameter lambda, only one parameter lambda, right? And probability, the formula for the Poisson distribution is e to the power minus lambda, lambda to the power x over x factorial. So what is your lambda basically? And x goes from 0, 1, 2, and it does not stop. So lambda is basically the average number of occurrences of something. Whatever they are asking, then on average, how many times it occurs is your lambda. Okay, so that is usually given in your questions. Something occurs 5 times per year on average. What is the probability that next year it will happen 10 times, right? So they can ask you anything like that. Let x be the probability that there will be on average the number of time it rains in Buremi is, let's say, 3 times in a year on average it rains, right? Now next year they may ask you, let's say, what is the probability that there is no rain in next year? Means zero number of times, right? So on average it means lambda is equal to 3, and then they are asking you for x is equal to 0, probability of x equal to 0. So anything can be found here. So uh, if lambda average is given, you can directly use this uh, uh, formula to answer the questions. Let's say if I have binomial This was binomial distribution. And after that, I did not do that as well. So here, nature of the Poisson distribution. Right, properties of Poisson distribution. So Poisson distribution is the how many times something happens. You see, the property distribution of a Poisson random variable x representing the number of outcomes. You see, representing the number of outcomes occurring in a given time or interval, or in some region denoted by t. So that is basically your where lambda is the average number of outcomes per unit time. Outcomes per unit time. So see here, during a where has it gone? Here, what is the problem? This is the example. Uh, During a laboratory experiment, the average number of radioactive particles passing through a counter is 1 millisecond. In 1 millisecond is 4. You see the average number of radio passing through a counter in 1 millisecond is 4. What is the property that 6 particles enter the counter in a given millisecond? So see, the same. This is not changing. They give you for 1 millisecond lambda is 4, right? And they are asking you the same 1 millisecond. So lambda does not change. Let's say if they give you the average in 1 millisecond, but they ask you what is the probability that in next 5 milliseconds, then I will not use lambda in the formula. Then my time is changed to 5. So my new lambda will become lambda into time, right? Which is 4 into 5, which is 20. So lambda will become 20 because given was 1 millisecond, they were asking for different millisecond. But here both are the same. So that's why lambda did not change. Lambda t is still t is equal to 1 here. But anyway, lambda is given and they are asking you the probability of 6. So this is x is equal to 6. What is the probability that 6 particles will pass? So I can just use e to the power minus lambda, lambda to the power 6 by 6 factorial. Important thing in Poisson distribution is this. Uh, we can approximate a binomial distribution using Poisson. Approximating binomial. What is that? If n is large, p is small, right? So that your multiple np is moderate, less than or equal to 10, not very big. Okay. Usually they say n has to be greater than 100 and p has to be very small so that np is 10. Okay. So p is very, very small, right? But n, so no condition on that. Usually n greater than 100 and np is less than 10. We can use Poisson for binomial. The same question. So what I will do, I know that the lambda is the mean of Poisson and the mean of binomial is np. So we multiply n with p and call it lambda, and then we use Poisson for binomial case. Okay, so basically the probability using the Poisson will become e to the power minus lambda, lambda to the power x by x factorial. This will be formula, and this will approximate This approximates your formula, which you have ncx p to the power x 1 minus p to the power n minus x. They both will give you the same answer. When n is very large, this is easy to use. Easy to use when n is large. Okay, very large. So that's why we prefer this one instead of that. Okay, if you look at the problems in the assignment, you might see if you go down here, see here, you might see it's a problem from binomial, but n is very large, x is small. See here, the probability that a person will die when he or she contracts a virus infection is this one. This is the probability of dying from a virus infection. Of next 4,000 people, so see this is my n, what is the mean number who will die, right? So see question 10 here, assignment 4, question 10. So basically they give me n is equal to 4,000. Of next 4,000 people, what is the probability that, so this was the probability from dying from that virus, 0.001. Very small, you see, p is very small, n is very large. N is very, very large. P is small, but when I multiply these two, I will get 4, right? 4 or 40. 4, right? N is 4 less than or equal to 10. So both are satisfied. It means like this is a binomial question. X has a binomial random variable with n 4,000 and p 0.001. But we say that this can be approximated, right? This can be approximated by Poisson distribution with lambda, where lambda is equal to np, which is 4. So therefore, probability of x is equal to x is e to the power minus lambda, which is minus 4, 4 to the power x by x factorial. And x will go from 0 to 4,000, right? All 4,000 can die, but the probability will be very, very less. Now, whatever they ask, you can answer the question from here. But over there, they ask you what is the mean number of deaths? What is the mean number who will die? Mean number is lambda, which is np, which is 4. That's it. This is the answer. No need to find any probability here.
Mr.
Ji.
You will write the formula in the exam paper.
Which formula? Is there any difficult one? If there is any difficult one, I can give you that. These formulas,
It's
like this formula, this is very simple, right?
Mr. But same. Almost it's
You
all
cannot
same.
remember this e to the power minus lambda.
Maybe, Mr.
Basically, you don't do practice. This is the problem. If you practice, these formulas are very easy.
I
Anyway, I
do
will see if I can write that.
Okay, Mr.
I wrote the correlation formula. Correlation regression formulas were difficult. I wrote them, right? So these two are your discrete random variables. We have one continuous random variable. X has a normal distribution with mean and standard deviation. Here, the parameters are mean and standard deviations. N for normal distribution, where mu is the mean and sigma is the standard deviation, right? So if mean and standard deviation are given, you can find the properties. Here, because x is continuous random variable, x is a continuous random variable, so it means it should have a PDF, right? So it needs PDF. You know that continuous random variables have PDF. They don't have formulas like binomial and Python. The PDF is little difficult PDF, which we cannot integrate to answer. This is the PDF of normal distribution, right? And there is no integration for that. So if you have to answer any uh, probability question for a normal distribution, what we do, we define a random variable which is z. If x has a normal distribution, if x has a normal distribution with mean, mu, and sigma standard deviation, then this variable z variable has a standard normal variable, means its mean is always 0 and standard deviation is 1 always. So this is what we call standard normal variable. Standard normal variable. X is a normal variable, Z is a standard normal variable. Sometimes they call it standardized normal variable. So what we do, we change this to X, Z, sorry. Whatever is given, we change X to Z. And how we change? We find the value of A in Z. We replace A in Z. So A minus mu by sigma, right? This will become the value of A in Z, right? And then B minus mu by sigma. It will give me the value of B in Z. So whatever you can write A, B, A, Z, B, Z, whatever. These will be new numbers, right? Then the tables are given because you know that the probability is the area under the curve. This is the area, this is the standard normal curve. Okay, 0 is in for Z. If you want to find the area between any two values, right, or whatever, your table is given. We can find these areas using the table, standard normal table. Okay, so if they ask you what is the probability that Z is less than some value Z, right, you get directly from table. This is the value. If this is your Z, you want area below that. So table gives you this value directly. Directly from the table, you will get this value. Okay. If they ask you the probability of Z greater than some number Z, this right side, this is the greater than, right? Z greater than Z. You cannot find that from the table because table gives you this value. Table gives you the left value, left of Z. So for the right, I can find the probability by 1 minus the left because the total probability is 1. So if I subtract left probability from 1, you will get the probability on the right. Okay, so left probability directly from the table. Right probability 1 minus left, and left comes from the table, right? And if you are between two values, Z1 less than Z less than Z2, right? This type of probability where you are between two numbers, Z1, Z2, then you will take the right probability first, Z minus this probability, and then you take this left one and subtract. Okay, so area at this and subtract this one, you will get the middle one. Okay, so for example, if I find the area below Z1, I get this whole area, right? I get this whole area on the left, but I don't want this area. I don't want this area, so it means I can subtract this area. This area can be subtracted from the whole area. So this is this area, and this was the whole area from here to here. So if you subtract the smaller one from the bigger one, you get the area between two of them. So this and these two directly come from the table because it is the left of Z2 minus the left of Z1. left of Z, left of Z. Here it is left of Z2, and this one is left of Z1. So if you subtract left of Z1 from the left of Z2, you get just the middle area. So see here, for example, you have given a standard normal distribution, find the area of the curve that lies to the left of this. To the left of this means probability of Z to the left of minus 1.39. This is what you want. Area to the left of, and this directly comes from the table. So if you go to the, there will be some table here, standard normal table. This one, this table will be given in your, so you have to find 1 minus 1 by 3 on the left. That's a probability of Z less than minus 1.39. So what you do, you look at in the table, you look at 1.3 on the left, first decimal up to first decimal on the left, and 0.09 on the top. See, this is the second decimal. So minus 1.3 and 0.09. If you add, this will give you minus 1.09. So this on the left and this on the top of the table. So if you look at minus 1.3 from the left and from the top 0.09, this area will be your answer. OK, so if you go to the table, minus 1.3. This is minus 1.3. And from the type 0, 1, from the top 0.9. Right. So here is the last column is 0.9. So if you see minus 1.3 and the last column, this one. Right. 1.3 last column, this. So 0.0823. So this is 0.0823. 0.0823 from the table. OK. They said on the right of, to the right of 1.96. To the right of 1.96, I cannot get it from the table. Table gives me to the left only. So I will just subtract 1 minus less than point, greater changes to less. And this is the left area. So now I can see 1.96. Right. So I will see 1.9 on the left and 0.6 from the top and see what is the answer here. So 1.96. Let's see here. So 1.9 is down there. First negative value is then positive. So 1.966 is first column is 0. 1.90, 91, 92, 93, 94, 95, 96. This is the seventh column. 0, 1, 2, 3, 4, 5, 6. This is 1.96, 0.9750, 0.9750, 0.9750. So now you subtract it from 1. So 0.0250, right? So that will be the area on the right. And if they ask you the area between two values, right? You see between these two values, so you have to subtract the right minus the left. So minus 26.65. 2.16 less than minus 0.65. So here, what you will do, you will write the right first, left of the right point minus left of the left point. OK, so whatever is on the right, that goes first. Minus 2.16 minus 0.65. So this will go first. You will subtract this one from this one. OK, so you can write minus 0.65 minus 0.65. Minus 0.6 is this, and 0, 1, 2, 3, 4, 5. So 0.2578 and minus 2.16. Minus 2 is above. Minus 2.16. 0, 1, 2, 3, 4, 5, 6. 0.0154. Right? So now you can subtract and get that. So this is how you find the probabilities between two values. Um, if I go to the next one, I will give you something like this question, right? Where it is written as so you have to find your x and mean and variance. For example, a research scientist reports that mice will live an average of 40 months when their diets are restricted. So see, on average of 40 months, so it means this should be my mu, 40 months. Assuming that the lifetimes of mice are normally distributed, so they told me that it's a normal distribution. So I can say that let x be the lifetime of mice because that is normally distributed. So question 7, assignment for question 70. Let x be the lifetime of mice, right? They said the lifetime of mice is normally distributed, right? With mu and sigma, where mu is given average lifetime of mice is 40, and here they gave me standard deviation with a standard deviation of 6.3. So see, both things are given. Mu and sigma are given to me, 6.3. Once mu and sigma are given, directly write. So first step is that, oh my God, I don't know whether I saved it or not. This is bad. Let's see. This is now. So we have saved, but up to what? Up to Poisson distribution. So maybe I can now leave a page. You can watch the video and fill the page, right? It accidentally closed. So anyway, you have the recording. So whatever I wrote for normal distribution, you can write it here. So I was doing A4 question 17. X is, we said let X be the lifetime of mice, right? So they said in the question, then X is normally distributed with mean mu and variance sigma, where mice average lifetime was given as 40 months and sigma was given as 6.3. Now, after that, uh, so this is your step 1, write X, right? Then step 2 is directly write Z. So your Z is X minus mu by sigma. So it becomes X minus 40 by 6.3. So this has a normal distribution with 0 mean and unit variance, right? So this is, now go to the questions. Now go to the questions. After step, they said, what is the probability that, find the probability that the given mouse will live more than 32 months. What is the probability that lifetime of X is more than 32 months? You see, mouse will live for more than 32 means the lifetime of that mouse is more than 32. So X is the lifetime, X is more than. I have to change it to Z. I cannot just get the answer. I have to change this to Z. So I will write 32 in Z first of all. So what will be that? 32 minus 40 by sigma. I will put here. This is my X. So I will put X here. 32 minus 40 is minus 8 over 6.3. If you use calculator, you will get 8 over 6.3. So this is 1.269. 1.269, but I will round it to 2 decimal places because my table is only for 2 decimal places. So this is 1.27. Now it is on the right. This is the probability on the right side, right? So this is 32 on the right side. I cannot get the right side. So right is 1 minus probability to the left, right? So this is what it is. So I will subtract 1 minus, because table gives me this probability. 1 minus that less than 1.27. So this probability is given in my table. So I will subtract it from 1. So 1.27 is down there. Go to 1.2. This is 1.2 and 7 is this one, right? 8th column. 1.27. 0.8980. 0.8980. So subtract from 1, you get the answer. What is the probability that a mouse will live less than 28 months? This will come directly from the table. Between 37 and 49. So let's say less than 28 is easy because direct use of table, but you have to change 28 in Z. So 28 minus 40 over 6.3, you will get this value. Put it here and get the answer. But the next is C part is between 37 and 49. Between 37 and 49 months. Now I have to change these two values to Z. Two values to Z. So 37 in Z minus 40 over 6.3. This will be 37 minus 40 divided by 6.3 is minus 0.476. So minus 0.476. So I should round it to minus 0.48 because my table is only up to 2 decimal places. And then the right is 49. 49 minus 40 divided by 6.3. So 1.428. 1.428. Again, I can round it to 1.43. Right? 1.43. So now I will write the left of the right point, 1.43. This comes first and minus this goes second. Okay. This is the afterward. The left point is after that 0.48. So now 1.43 and 0.48. So 1.43. 1.43 is this 0.2936. See 1.4 and 0.3. So this one 0.9236. And minus 0.48. So that's above minus 0.48. This is 8 minus 0.48. This one 3156. So that's that. Okay. So if a normal distribution question is given like this, right? So you have to be you have to define. Step 1 is define X. Whatever they are asking you, that is your X, right? Let X be the time a mouse will live. Basically, that is the lifetime, right? Lifetimes of the mice are normally distribution. So you can call this X. Let X be the lifetimes of the mouse. And that has a normal distribution with mu 40 sigma 6.3. Now you can answer using the table any question that they are giving.